Hello, everybody. Are we ready? Yeah, we are ready. So, welcome everybody to my presentation about Scala macros. I wanted to make the title very catchy, although I'm aware that there is no silver bullet in software engineering. But Scala macros, or maybe speaking more generally, meta-programming provides very flexible way of thinking about writing code. Yesterday we had a talk about ScalaJS and JScala, which heavily uses macros. So today we'll try to demystify a little bit internals of them, how to use them, and grasp the essence of macros. So, okay. It worked. So, about me. I'm Bartosz Bąbol. I work in Javeo. We are located in Warsaw, in Poland. We do applications mostly in Java and Scala using, you might call it, reactive technology stack, right? So here you've got my Twitter nickname and link to my blog, which, by the way, if you will find this topic interesting, I have written 3 blog posts about Scala macros. So then you will find more configuration, then you will find more configurational details or more internal details. So I encourage you to preview them if you will like this topic. And of course, you can always give me some feedback, right? And just to sum up this About Me page, I'm just a regular developer who tried to use this language experimental feature, and today I want to share with you my experiences from this experiment. So, let's get started. And what about some traditional survey? How many of you have heard about Scala macros? Yeah, John, I know you heard. And so how many of you have used Scala macros? Yeah, John, I know you have used. So that was predictable, that's minority of you. And because this is a screenshot from the documentation, and as you see, the sign here says that this feature is still an experimental feature. So it's experimental, but it's heavily used by developers. And we'll see examples later, example of libraries which uses macros under the hood. So to the point. Today we'll try to grasp the essence of them. By the way, documentation is very good, extensive, with a lot of theory and examples, so I encourage you to preview it. And let's get started. So, according to the fantastic presentations by one of Scala macros creators, Eugene Burmako, macros are good for 3 things. So, code generation, static checks, and domain-specific languages. So, I have included a link to this presentation at final slide of my presentation, so if you will find this topic interesting, I encourage you to preview it. So now we've got a little idea what they are good for, so let's go a little bit deeper. I have included here some bullet points about Scala macros, just to give you a bigger perspective. So what are macros? What are key features? They allow metaprogramming in Scala. And what's metaprogramming? It's the effect of metaprogramming might look like this. So we've got some complex, hard to drive machine, which is very powerful, but hard to drive. And you want to use this machine, which is nice, simpler, easy to drive, which is important, but still have got features of this machine. So metaprogramming, it's the effect of metaprogramming. Yeah? You can replace something bigger, complex, to the easier, nicer syntax for me. And they are expanded at compile time. It's important. I was writing Ruby before Scala, so for me it's a killer feature. And they allow manipulate AST, and whatever AST is probably better than string, because string is primitive. So they are great for building libraries. We'll see examples later, and they are written in Scala, so you might use your favorite language, or my favorite language, to write them. So, this is how I imagine macros. So we've got some machine, which is simple, but somewhere under the hood can keep enormous amount of logic. So macros can transform your codes from simple to advanced. And what is metaprogramming? So you might like to think about metaprogramming as some kind of magic, because what it does is a little short of magic. And what do I mean by that? So maybe you have watched the movie Inception, the one with Leonardo DiCaprio, right? The movie is about dreaming inside some other dream. So there is some kind of story where people could get inside some other people's dream, do something inside this dream, modify it a little bit, And I know it's kind of abstract for those who didn't watch it, but this idea of dreaming inside some other dream is kind of similar to metaprogramming, which is programming inside some other program. Yeah. So metaprogram is a program which takes as an input other program, modifies it a little bit, changes its behavior, and returns the new program. So is metaprogramming specific to Scala? Is it a new concept? Of course, both answers to this question is no. Metaprogramming exists in many known languages, many popular languages, and it is considered as very controversial feature. And why is this considered as controversial feature? Because, you know, macros or metaprogramming gives developer a lot of power, and with a lot of power comes great responsibility. So what do I mean by that? What do I mean by a lot of power? Let's look at those examples of C macro, of macros in C language. So what this code does, it replaces this code snippet for each with this code. So compiled program will look slightly different than this written by developer. I have also included here conditional compilation, so depending on the platform you write code, the proper code will be compiled, right? So it might be useful if you are writing some library for mobile platforms, and different mobile platforms like Android or iOS have different code requirements, so you might choose which code should compile depending on platform. So if you haven't seen those examples before, you might be having a great time right now, but now let's look at this beast. And what this code does is replacing occurrences of true to false, right? So if you are a developer who likes jokes, it could be very tempting to write something like this, but the consequences might not be so good for you. I don't have to explain it, why, probably. But this is valid and possible to do, and this might be a reaction when you see this code. When you see, you know, this is the example of C macro weakness, right? Because it gives you a lot of power, but with a lot of power comes great responsibility and so on. But they are kind of primitive macros. So this is the example answer to the question why metaprogramming is so controversial. Yeah. So we are back to Scala now. I have said that macros are widely used by developers, and these are some Scala superstars, right? Superstars libraries, which somewhere under the hood use macros. And we'll focus a little bit more on play framework, just to give some example. So, okay, so this is our case. We've got case class, and we want to transform it to JSON, right? It's a very common situation in web development, not only. So, how to do this in play framework? And don't get into syntax too much. This is how you can do this in play framework. And even in such concise language as Scala, you have to deal somehow with boilerplate code. It's nothing wrong with this code, but actually it's a rewritten car class. So let's think about code on the left, this case class definition, as a bag of words, a bag of tokens, right? So you've got this year, string, weight, model, right? These are tokens. Let's think about it. If we would have some kind of mechanism where you could grab those words, grab those tokens, rearrange them a little bit, add some new syntax, then you could achieve code on the right. And of course, this is not my idea. Somebody has this idea before and tried to implement this. So this is the result, and this is the equivalent of the previous code. So in Play Framework, you can build a custom mapping to the JSON using this writes method, right? So redundant code is removed. This is easier to read, probably easier to debug. And so let's check how this method is implemented. And let's look at file JSON Scala. Where's the implementation? So this is the comment from the implementation. And what this comment says is that this code highlighted on red, maybe you don't see this because it's, no. This code highlighted here is replaced with this code highlighted on blue. So actually that's what we want. So let's look at the implementation. And it looks very concise if we only knew what this macro keyword means. So let's start with some simple examples. Look at the simple method invocation. Do you see something weird here? Something specific? Something not usual?
Hello is in italics?
No, the developer from outside cannot specify that this is implemented using macros or not, so fine that you Because on the previous conferences, many people have said something about this code, that this is wrong, this is wrong. They try to, find some mistakes. But this is plain simple code, right? So developer from outside cannot specify if this is implemented using Scala macros or not. So let's look at this implementation of this hello method. So this is object welcome, and what is important, this object has to be specified in different compilation phase, so different SBT project as you wish, right? So, but this is some kind of configurational detail. You can easily do this in SBT. You will find examples on my blog post and so on, and not only on my blog post. So, signature of this def hello looks pretty straightforward. This is the method which takes a string, returns unit. But what is this macro keyword? And the macro keywords this is how you select implementation of your macro. So the real implementation is here. This is hello implementation. This is implementation of our macro. So let's focus a bit on this. So it takes two sets of arguments. First one is context. Second one is mysterious tree. And this implementation also returns tree, whatever this tree is. So let's focus on imported packages and let's preview this code. So look at the import clause. We've got package black box, and macros in Scala come in two flavors. If macro faithfully follow the type signature, it could be treated as black box, so it's called black box. If type signature is only some abbreviation, right? It's only some approximation, then the macro is called white box. If you're writing dev macros, so example on this slide, then it's more confident to use black box macros. So this is how documentation says that you should say black box macros when you're writing dev macros. And now we'll take a look at implementation. And I have said a couple of slides before that meta program is a program which takes as an input another program, modifies it a little bit, changes its behavior, etc. And this is what this implementation does. So it takes as an input some kind of parameter which is type 3, which is piece of your code. This is piece of your program, and returns new modified program. You can think about this tree as a piece of your code. So let's start with some theory. So let's repeat what macros are. And macros are functions that are called by compiler during compilation, right? So within these functions, the programmer has access to the compiler API. For example, it's possible to generate, analyze, and type check code. And you need some API for this. So this context is a wrapper around universe from reflection package, and you might think about this context like about API for metaprogramming. So second parameter is tree, and this is the type which represents abstract syntax trees. So in macros implementation, we'll operate on low-level structures like 3 elements of code. So code after being parsed, but before real compilation is structured into AST, abstract syntax tree. So we can arbitrarily modify those structures, and compiler will tell us that our result is good or not. So we'll see later advantages of it. And the last thing is returning type, and as I said, it's also tree. As you see, it's also tree. So the last part of macro is the real implementation, right? The body of our implementation. So current year is an integer with the current year, nothing fancy. But what is this Q interpolator? So it's called quasi-quotes, and returning type of our implementation will give you a hint what these quasi-quotes produce. It produces AST, it produces some kind of structure. So you can build your code with ease using this construction called quasi-quotes. And let's look closer to the last line of macro, at the last line. So this line is pretty important. You can use this Q interpolator to build AST. It looks similar to building a string, so the syntax is commonly used by Scala developers, right? But what is this AST tree? So AST is core data structure used in compilers. So let's say that we've got following piece of code, 1 plus 2 plus 3. And early stage of compilation is lexical analysis, and what it does is checking the sequence of code elements and assigns them to tokens. So this is how your code might look like after lexical analysis. And each sign is assigned to some token. But there are also redundant signs like parentheses, for example, right? So compiler needs simpler data structure, for example, without these parentheses. And this is how you can imagine AST, right? It's some kind of structure which compiler understands This is the information for compiler how the code should be evaluated. And I have included two versions of it just to give a bigger perspective. It's a very simple example, right? So let's say that you have created some language with an API for building AST. So and plus is just some code token used to build this code, right? So why I have written this in a weird way? Why I have written this in this way? So let's go back to our example. And this code also builds AST. So QInterpolator allows you to build AST easier. So if it allows you to build AST easier, there should be also harder way. So what this expression produces? So this is generated tree, and it looks a bit more complicated, in my opinion. And each of these objects are subtypes of tree, and it is possible to build this code in this way. So let's compare those two ways of creating AST. So those simple two examples are just to show you the power of quasi-codes, right? You might choose the way you are building your code. On the left you've got quasi-codes, on the right you've got corresponding trees. So, this is the example. Even such primitive constructions are kinda more complicated in tree subtypes. So I want to highlight the power of macros. So how they simplify creating AST. Quasi-codes also come in many flavors. In documentation you will find different interpolators for building different structures. So if you want to build type, you will use TQ interpolator. If you want to build body of the case clause, you will use CQ interpolator. If you want to build for loop enumerator, you will use this FQ interpolator. In my blog post you will find other examples of these interpolators. This is from the documentation. You will also find this in documentation. So okay, so let's look at a bit more practical example. So we've got some method and we want to benchmark it. We want to have information how much time this method takes to execute. Okay, so this is how you can achieve it, right? It's nothing fancy here. It's just, this is body of your function, and we wrap this body with some timestamps, and we print the difference, time difference, just to show how many time method takes to execute, and we return the result of our method. So nothing fancy here, but what is wrong here? So let's look at this wrapper. This is boilerplate. It's not important for understanding the method behavior, right? It's not important for developer at all to see this. We just want it to test method, for example. And moreover, we have to touch method. We have to modify it a little bit. So the best option would be not to change method body at all, right? This would be the best case. So this is one example how you can achieve expected behavior using macro annotations. This is a different type of macro, and which allows you to write annotations which can change annotating definitions. If you have been at yesterday's talk about Scala, maybe, then somebody wrote an annotation JavaScript, right? So this annotation also was macro annotation, which does some weird thing, which was doing converting Scala code to the JavaScript. This annotation will do something very much simpler. It will just add some wrapper, some values. So, okay, so on the left we've got our expected syntax, and on the right we've got result of our modification. So how to achieve this using Scala macro annotation? So this is definition of our macro. What is important class benchmark is extending static annotations, right? Which specifies how implementation of macro annotation should look like. So method macro transform take parameters which are called annotees. So there are elements what we are annotating. So for example, methods, classes, values, whatever. And next we've got macro keyword and following implementation. So let's focus on implementation. And this is an implementation. So let's focus on specific parts of it. And there are a few differences between def macros and macro annotations when looking at their implementation. So one difference is we need to implement macro transform method, as I said before, and it takes context and annotees as arguments. So you might think about this expression as some kind of wrapper around AST. So you remember context gives you the whole API for metaprogramming, so compiler methods, type checking, analyzing code, and so on. So now let's look at body of the implementation and what's going on here. So annotees is sequence of annotated definitions. So this is sequence of code elements you are annotating, and we want to have them in form of AST, right? So we are mapping through this collection and converting each element to AST node. So next outstanding feature, outstanding in my opinion, feature is extractor pattern. So what quasi-code gives you, it is possibility to extract and pattern match code elements. So you've got this case clause with some pattern, and you can extract what is important from your code. So maybe this is a good way to say, I have said that whatever AST is, it's probably better than string, right? So this is the good moment to say that how you would pattern match code if it would be a string, for example. So with some kind of regex expression or whatever, it would be not fun at all. And this is very readable, very, how to say, very readable, very nice syntax. But look at this 2 dots and 3 dots signs. What do they mean? Let's focus a bit more on this case clause. So these are patterns, and this is pattern which says, here I expect list of 3. And 3 dots means, here I expect list of 3. And why is that? Because method can take one set of arguments, so list of 3, and many sets of, one set of type arguments, and one set of arguments which is list of 3, right? So these are patterns which allows you to easily extract whatever is important from method or class or whatever. Okay, and this is the implementation of, this is the building of AST, of our new method. And we are building the same method with the same signature. We are assigning body of our method to some result, value result. We are returning this result, and we wrap this code with some kind of boilerplate. This is boilerplate. This is, you know, just timestamps, yeah. And we are print lining the difference. So it is human readable code. You can read this, and you still don't have syntax highlighting, but I think it's still a big improvement from the previous version, when you have to build code from 3 elements. So maybe let's look at this example, and I have said that macros are expanded at compile time. So let's change this return type to something static, like string, for example. And we remember that our method, annotated method, was returning integer, right? Because we are powering some number to some power, right? So what will happen if we will change this return type to string in this example? Yeah, of course, we'll have compilation error, right? So you still got a lot of power, but the common mistakes would be cached by the compiler. So when I was thinking about examples for this presentation, I have started to look on Stack Overflow. On tag Scala macros, you can find questions about, without surprises, Scala macros. And I have found a question about converting case class to map. So I have included link to this Stack Overflow question. You can preview it later. And somebody who have asked this question, he wants similar behavior. So you've got some case class with some fields. You are instantiated those case class, and you've got method to map, which converts this case class to map, where keys are names of your case class, and the values are values of those fields. So on this Stack Overflow question, you will find solution how to do this with def macros. So I will not repeat this solution, you can preview it by yourself. We'll try to implement this using macro annotation. So we want to have this mapable, I call it mapable, whatever, mapable annotation, which at compile time will add this method to map, and result of this method will be map with keys as name of parameters and values as values of the parameters. So this is an implementation, and let's preview it step by step. So it's very similar to previous examples, so I will preview it very quickly. So imports are the same as in benchmark example, so nothing new here. We are implementing class which extends static annotation. The class has name mapable because our annotation is called mapable. So it's almost the same as benchmark example. And final implementation of our mapable annotation. So structure is again almost the same. What differs here is this case pattern. in the documentation you will find different patterns for different annotees. So case class will have different pattern than definitions, right, or values. So, so let's focus on implementation. I didn't include it on this slide because it wouldn't fit on this slide. So, skipping the whole required syntax, this is the body of our implementation, and what it does, we are extracting what is important from our class, and we are building new class with the same signature, with the same, you might say, body of the class, and we are adding here this toMap method, which returns map string to edit. And what this map is here is some kind of value where I have map over params, I convert them to strings, and I zip with the values of the params. So nothing fancy, but this trivial example is just to show you that here you can do a lot of magic. You've got access to the compiler functions and so on, so you can build something more advanced. So more examples and code you can find on my blog in mentioned earlier posts. And so these were some kind of small examples just to fit you in the context of metaprogramming things, right? So what you should be aware of now is that Scala macros are about building code from some kind of tokens from 3 elements and replacing old AST with the newer modified one and compile them. So now let's look at use case we had in one of our recent projects. So we have written a very small library which is called Grizzly, because grid, and the dangerous bear Grizzly because macros are so dangerous, right? But why grid? Why grid? What was our main problem? So on this slide you've got typical front-end table with filtering, sorting, ascending, descending, dynamic pagination, and we had a lot of these tables in one of our recent projects. So we had a lot of our recent projects. The project was written in Play Framework and Slick for access to the database. On the front we have been using AngularJS, but this is not important at all in this case. So working example from this slide you will find on Java's GitHub, and let's dig a little bit deeper into this problem. What is Slick? So Slick is functional relational mapping for Scala, and what it does in 2 words, it just transforms Scala code to SQL syntax. So this is an example what Slick does. You've got some Scala code and it transforms to, for example, in this case, select query. So let's look at the example how to implement sorting in Slick for our purposes. So let's say that in our example we've got users table, and don't get into syntax too much, it's representation of SQL table. We've got this table and we want to implement sorting in this table. So let's preview necessary methods. So in Slick API you've got methods which allows you to make result which we expect. So Slick API is very similar to Scala standard collection API, and as you suspect, filter, you've got filter methods, drop and sort by, which help you implementing pagination, sorting, and filtering things. So filter query is to build select query where you can drop some elements and take some elements, and this is how you can achieve pagination. And you can sort by some column, ascending, descending, and it will produce select with order by. So now let's use those methods to create full pagination needed for our example. So there's a lot of code, but there's nothing special here. We pass parameters from frontend, and depending on the parameter, we are building slightly different select query, right? So what is repeated here? What tokens from this code exist in each line, and it would be great if they would be generated. So what I want to highlight right now is boilerplate code. This code is repeated on each line. Look at these terms, look at this code in terms of bag of words, like in this example with PlayJSON framework, PlayJSON example. So you've got some words, and which words do you need to generate rest of the syntax? So what differs is case parameter. It's slightly different, right? Because you've got different parameters, and sort by function argument body. So actually, what we can treat as boilerplate code is ascending, descending, because we want always to have sorting, ascending, and descending, right? So it's also might be considered as boilerplate. So if we remove ascending and descending from this code, then we have got each column name token repeated, so we can get rid of the repetitions. So, okay, code is simplified. Do we finish now? Can we do better? And this is Leo from the Inception. This is the man from the Inception, and he says that there is still too much boilerplate. Okay, so actually, from this perspective, it looks like only your column names are important to generate this whole code of sort by. So, because this is the one element which differs in each line. So, if we will only have those tokens, then we could generate rest of the code. Or maybe to be more specific, we could build bigger AST. So, now we've got to filter our columns by some parameter, and still syntax is not important. We've got some boilerplate. This is what differs. If we would have this, we could generate rest of the code. So, this is the fun part of writing macros. So, this is the fun part requiring your imagination. So, how to design some kind of container for tokens, right? To tell developer, give me those tokens, and I will produce rest of the boilerplate. So you have to implement some kind of DSL maybe or syntax for providing tokens. A macro which will be used by macro to generate rest of the code. So this is how we try to reduce this boilerplate thing. So we thought that you have to provide query, which is SQL query, and define columns. And if you will define columns, then sorting, filtering, and pagination will be generated. So for comparison, I wanted to compare those two code amounts, you might say. And actually, the code on the right couldn't fit on the slide. So imagine that there is someone going to the hell, straight to the hell. And what is important? On the left is less, on the right is more. And this is the main idea of macros. This is the main idea why we have used them to build some kind of small library, as I said. So, if you are interested, full generated code is on Java's GitHub. You can preview it, also with the source code of this macro, of course. And so let's look at the syntax again. What developer has to specify is set of columns, as I said, the query, default sort by, because it was useful for us. You also can write this equals, which means that you will be filtering by comparing equality, and if you will not write this, you will have filtering by like. So the syntax of this library is not important in this presentation. So what I wanted to highlight here is some language feature which helps us reducing redundant code, right? So you might argue that this syntax is fully free of boilerplate. Maybe you've got idea how to simplify this even more. But why I did it in this way? Because one of the problem was IDE support, and yesterday's talk about Scala, the guy who was talking about Scala also had the same problem, because IDE couldn't see generated by macro methods, and it's kind of problem. But so I thought that would be easier, that you have to provide some types and developer would know how the rest of the code should look like. So what else? Okay, so let's go back to problem with IDE support. You've got some problem with, we've got some problem with, IDEA has some problem with seeing the methods generated by macro annotation. So let's stay with Grizzly example. And this code is from example project from GitHub, and it looks very suspicious. I mean, it's all highlighted on red, but it compiles properly, right? So it's kind of confusing, and you don't want to see this in your project, right? So let's look at this value search result. You instantiate users grid and you invoke this method run. And maybe as you remember, in users grid there was no method run, so probably it's generated by macro and IDEA cannot see this. And this is magical and fun to write, but it would be pain to use library in best case with documentation without any coding assistance provided by IDE. And as you presume, there is a solution for this problem. So personally, I'm using IntelliJ IDEA at my everyday work, and when I have started to play with macros, I was a little bit disappointed. So for example, if macro annotation add new method before compilation to annotated class, this method is invisible for IntelliJ IDEA because its coding assistance is based on static code analysis, and this is why it's not aware of AST changes. And in October 2015, IntelliJ published this post, and it was explained that IntelliJ is providing small API for writing plugins to IDEA just to support macros. So actually writing your own IDEA plugin is not hard. It's not that hard. It's actually very easy. You will find example on my blog post how to do it. It's very easy. Just implementing one method actually, and you will find example repository also on my GitHub. So it requires a little bit more effort to make your macro fully complete, but still I think that in some cases it might be worth it, right? Because you can still spend some more weekends doing IntelliJ IDEA plugins, which is kind of fun. And debugging. I didn't prepare this slide. Yeah, debugging is a little bit different than debugging your code, because how I was writing this library, I knew how the expected code should look like, so I was a little bit reverse engineering, right? Firstly, I write this code in Slick, this whole boilerplate, and then I have started to step by step replacing the snippets of code with my macro. So you've got also showRow method, which gives you output of generated tree, and you've got also showCode method, which prints you the generated code, so you can show code, copy the output, replace with your macro, and this is how I debugged my example. Okay, so what I wanted to give you today, we are going to the end, and what I wanted to give you today is taster for Scala macros. So I use them to hide complex logic inside simpler syntax, and the reason to do this is to reduce places where developer can make mistakes, and the less code developer has to write, the fewer errors he will make, in theory, of course. And also the solution simplifies debugging. 45 minutes or 50 minutes is not enough to show you whole configuration of details, but as I said earlier, you can find examples on my blog post. So these are useful links which you can visit after this presentation. I encourage you to check it out. And I hope that I convinced you that to look more deeply at macros. If you do, it will result in faster development, more concise code, and more than a little fun as you master Scala macros, as it was in my case. So, thank you very much for your attention. Okay, questions? Hecklers? Where's the mic?
Well, in the start of your presentation, you show slides with different string quasi-interpolators.
Yes.
Is this different quasi-interpolators are composable?
Yes.
Can you explain how to do it?
Yes, for example, in Grizzly example, I'm generating code with a lot of case pattern. With a lot of cases.
Yeah.
So to do this, I've got a method, generate me AST with the CQ interpolator, and in some kind of loop, I'm generating whole code with CQ interpolator, right? Okay, so I then generated these whole cases. Then I placed them inside Q interpolator, which was responsible for generating rest of the methods, right? So I think that was your question. You can mix those interpolators. Yeah.
So
yes, but so probably it's the only way how you can use this CQ interpolator, right? Because CQ interpolator can build only body of the case clause, right? So you have to mix it with the Q interpolator, which builds the rest of the method. Okay. Some more questions, maybe some ideas how to use macros.
Once again about black box and white box in the macros.
So
the first your example use black box and next
yes.
Use white box.
Yes.
What's the reason?
So as I said at the beginning, if your macro faithfully follow your type definition, then it's called black box. If macro annotations, for example, you've got you don't have very strict type definitions, right? Because you can generate whatever you want inside the macro. You can change the name of the method, the returning types, whatever. So it's called the white box. So it's difference. The compiler probably will check if you mix with the types. And documentation says that you should use white box macros when you are writing macro annotations, because black box, when you import black box macros, it will not work. But I checked it and it works also. So, but I didn't dig into this problem too much. It works. I just left it. Okay.
What about supporting different compiler versions? I think that for like 2.10, 2.11, 2.12, you have to do some changes in your macros.
There was release of new Scala a few weeks ago, probably 2.12, and what has changed is also compiler plugin, which also has to update. So the compiler plugin is responsible for this update, right?
You mean macro paradise?
Yes, it's called macro paradise.
You talked about the idea of releasing some plugin or some plugin or some API to write your own plugin. So is it which version? Is it 15?
Yes. So question was about API for IntelliJ IDEA. Which version of IDEA you have to use this plugin? Yes, IntelliJ IDEA 15. I was using 15. There is also a newer version, 16, and it also works with 16. So up from 15. Okay. So thank you very much. I'm available here, so you can ask me if you want.